Hi guys, today's topic is fire. We're going to learn all about fire. And you might think of a lot of different things when I say fire. Some of you might think of campfires, roasted marshmallows, or hot dogs. Others might think about, you know, building fires like you learn about in fire safety and that firefighters put out. Other people might think about wildfires that are happening out west recently or in the past few years. You can even see some of the smoke coming affecting air quality here in Iowa. And others might think about birthday candles. I certainly always think about cake, you know? But all of these things are the same thing, the same process. They're all fire. But what exactly is it anyways? Well, in its simplest, fire is a chemical reaction. I know some of you might be like saying, ooh, boring, but it's actually pretty cool because fire is self-perpetuating. So what that means is that it will continue happening if it has all the ingredients necessary. So the things you need are a fuel like wood or candle wax or things like that, oxygen, and heat. And the reason it's self-perpetuating is because fire produces heat. So the heat that fire produces goes back to starting and continuing the fire. So I know that kind of is a boring explanation. So I'm going to take you through each part of the flame and explain to you exactly what's going on. So at the bottom of the flame, we have the fuel source. But as you can see, there's this little cloud right here where there's not actually anything burning. And also you can kind of tell that the wax isn't actually touching any of the fire. The wick brings some wax up, but it's actually not the solid that is burning. The wax gets vaporized into a gas, and that's what's burning. The same thing happens with wood. This is a process called pyrolysis. There's enough heat that it breaks off little pieces of the fuel source that then ignite when they're in the air. So to show you that this is actually what's happening, I did a little experiment. I took a really, really cold spoon that I put in the freezer and I stuck it right in that little spot where there was no fire, that little round spot, and it comes up with wax, even though I didn't even touch the candle. So that goes to show you that that area right in there was vaporized wax, that when it touched the cool spoon, it became hardened wax again. So the next part of the flame I'll talk about is the center part. You can see it's a bunch of different colors. And the reason it's different colors is because it's different heat. Like, you know that when something gets really hot, it starts to glow. Well, hotter things glow blue and then red and yellow. So the different colors represent different areas of heat. But what is it actually that's right here that is heating up? So in some cases it's the wax, but in most cases it's actually the soot. And what soot is, I know you all are probably familiar with it if you've been into a fireplace or anything like that. It's that little black stuff. So soot is pieces of the original fuel source, like wood or wax, that have rearranged in a different form and form these little black particles. And so these black particles get really, really high temperatures right here. So they emit radiation and look really pretty. And to show you that it's actually the soot that is causing this emission of light, I did another experiment with a spoon. This time I took the spoon and I ran it right through the flame. And as you can see on the back of the spoon, it's covered with this black substance. And it's not actually burnt, it's just the little pieces that attach to the spoon. So that's pretty cool. If I was to wave the spoon above the flame, it wouldn't catch any of the soot. And that's because by the time it's above the flame, up here, most of the soot has either been burned by the fire and all the heat, or is too far spread out. to actually come up with anything, but a little bit does come. And if I were to take the spoon again up above here, I would have water condensation on the spoon, because the fire, as we saw in the beginning, releases carbon dioxide and water, which kind of seems counterintuitive, but it's true. And one last point about the flame, it's got this cool shape. And it's got this cool shape because of gravity. You might think that's weird, but the hot air and the hot flame rises like this, and the cold air comes down to replace it. So that's why it has this shape. If there was a fire, say, where there's no gravity, like in the space station, the fire actually burns in a sphere, which is pretty neat. In simpler terms, people like to talk about fire in the fire triangle. The fire triangle is all the ingredients that are necessary for a fire to actually happen. And this is what firefighters like to think about when they're trying to put out a fire. So it needs oxygen, and you probably know that if you've ever tried to start a campfire. Sometimes you blow on it, or sometimes you gotta make sure the wood's a little stacked up so the air can get underneath it. And you need heat. Like we said, it's a self-perpetuating reaction, so it produces heat, but it also needs heat to continue going. So if somehow that heat goes away, the fire will go out. And finally, it needs fuel. This is the one that makes the most sense. Fire is not going to burn on nothing. So if there's no wood to burn or there's no candle to burn, it's not going to continue. And to show you this, I made another little video. And in this one, I have 3 different candles that'll show you what will happen when I take away different parts of the fire triangle. The first one I did was taking away the oxygen. So as you can see, this candle's burning fine when I have no cover on the top. But when I put this cover on, it limits the airflow that can come back in and doesn't allow any more oxygen to come. And once the fire has burned through all of the oxygen that's inside of here, it will go out. And that's exactly what happens. And then the next thing I did was take away heat. And the way I did that is the way a lot of firefighters try to take away heat. It's with water. So the reason water takes away heat, as you can see right here, the water is going to go in and it will put out the fire. And the reason it takes away the heat is because all the energy that would have gone to raising the temperature instead goes to changing water from a liquid to a gas. And then finally, I show you what happens when there's no more fuel source. So I took this little bitty candle and I burnt it all the way till it was gone. And it took a while and it was kind of boring, but it eventually finally went out once there was no more wax to burn. So in the rest of today's activities, I have 3 different sections set up for you with a couple of different activities. So there's fire and natural ecosystems. So fire is actually an important process in a lot of natural ecosystems. Like a lot of the woods out west depend on fire for a number of different things. So I have a video showing you why fire is important and how it impacts animals that live there. And then I have a little activity where you look at little tree slices. They're called tree cookies. And you might have you see the trees and they have the rings. Well, you can tell a lot from those. And you can see when there's been droughts or when there's been lots of water. Sometimes there'll be fire scars. So you can see the history of when fires have occurred and learn a lot through trees. And the next section is fighting wildfires and prescribed burns. In this area, you'll have different videos about how firefighters use different techniques to put out wildfires. And then there's an activity where you can try your own hand at planning what you would do to tackle a wildfire. And then finally, there's a section on fire and climate change. And here there's a podcast and a couple of other resources where you can learn more about how fire and climate change are linked. And at the end of all that, I have a couple of different crafts and coloring pages that are fun to do if you don't want to do any of the other things. I hope you guys have a great day. Thank you.